So we finally start talking about angles in this lesson. We're going to start with a bunch of vocab, and notation, especially in this lesson, is going to be important. Remember, I'm picky about that notation. So we're going to do all our notation stuff in this column here. Our first vocab word is ray. A ray is like a line, but it goes in only one direction. So we know lines go in two directions, segments have two endpoints, rays have an endpoint, and then they extend indefinitely in one direction. There's a couple different ways that we can name a single ray. Actually, it's just kind of one way, but multiple versions. We always start with the endpoint. So in this top ray here, my endpoint is M. And then to name the ray, I can use any point on the other end of that ray. So I could call this MO with an arrow on the top. Our arrows always point to the right. Or I could call this MP, and they refer to the exact same ray. Same thing with that ray on the bottom there. It is facing the other direction. Notice how the arrow is pointing to the left. We are not going to change the direction of our arrow when we name this. I'm still going to start with my endpoint C, and I can name this either CB, or I could name this CA, and they mean the exact same thing. The order here is super important. That order is the most important piece. If we do not have the endpoint coming first, then our ray is not labeled correctly. Some things that I want you to look out for and not do. I don't want to see us doing something like, BA, where we don't pick the endpoint. I got to make sure I pick that endpoint to be my first point. I don't want to see something silly like OM, where we change the direction of that arrow. Your arrow is always going to face to the right. Any questions on that? Okay, next vocab is opposite rays. An opposite ray simply is just two rays that share an endpoint, okay? And they extend in opposite directions. If we literally just look at that drawing right there, that looks pretty similar to a line, which it is. Opposite rays form a line. So I could go ahead and say that they share the endpoint J. And I have two rays extending out opposite directions from J. I have JH and I have JK, and those are opposite rays. Questions there? Okay, two rays make up an angle. An angle is a figure made up of two non-collinear rays, which are called sides. They share a common endpoint, so just like opposite rays. We call that endpoint a vertex. So in this diagram, that's letter B is our vertex. And I could have points on that angle, inside that angle, outside that angle, wherever. Naming angles is kind of tricky, okay? The easiest way, and I love when they do this for us, is sometimes they'll just put a number inside of that angle. So this angle could simply just be called angle 1. Do we see that? Sometimes they're not so nice, and they don't give us that number on the inside, and that's okay. Then we name our angles using 3 letters, 1 for each side and 1 representing the vertex. The vertex is always going to be that middle letter. So I could call this angle A, B because B is the vertex, C. The order of the outside two pieces doesn't really matter. So angle CBA refers to the same exact angle. These are the three most common ones that you are going to see. They are the most useful. They're pretty much correct every time. There is a fourth option here, which can sometimes get a little bit hairy, and it only works in diagrams that are shown with only one angle, or maybe there's two angles, but the angles are really far apart. It won't be hard to mess them up. Is we can just call this by its vertex. So angle B is also acceptable. However, again, this only works if there's only one angle. Or they're really far apart. Some things that I often see that I don't want to see is that we try to switch around our letters a little bit and we get things wrong. Remember that vertex has to be in the middle. So we could not call this angle CAB, even though it's all the same letters. That right there tells me that my vertex would be over here at point A, which it isn't. Questions there? Okay, next one is degree. We all know that angles are measured in degrees. They go 360 degrees around a circle. So 1 degree would be like 360th percent of a circle or whatever it is. So degree measure. Weird notation again. Do we remember back when we did notation for like segments and stuff, and I was telling you, okay, well, when we say that a segment is congruent to another segment, we include that line on the top. Do we remember that? But if I say that TU equals 5, then I don't put the line at the top. Do we remember me kind of saying that? Okay. Same thing kind of happens with angles. If I'm saying that angles are congruent to each other, I write them exactly like I did up there. But if I'm talking about their degree measure, I include a little m. That stands for measure. So it's a lowercase m. And I could say, let's use the angle from the definition above. Angle ABC equals 60 degrees. So anytime I'm actually talking about an angle's degree measure, I put that little m in the front. I don't know why, but we do. Questions there? Okay. Hopefully we've seen some of these definitions before. A right angle is an angle that measures exactly 90 degrees. If you notice in here, this symbol, that's like a little square box, that is the right angle symbol. You will see that quite often. It means that the angle measure is 90 degrees. So I could say that this angle, the measure of this angle, again, only one angle, so I can use that vertex. The measure of angle A equals exactly 90 degrees. Next is an acute angle. An acute angle is an angle that has a measure that is greater than 0, but smaller than 90 degrees, smaller than a right angle. So we could say that this angle here, which is angle B, its measure is between 0 and 90. It's greater than 0, less than 90. Some inequality signs in there for you. Similarly, but opposite to acute, is obtuse. Obtuse says an angle is greater than 90 degrees, but less than 180. So this angle here, I can see it is bigger than that right angle. So angle C is between 90 and 180. Any questions there? Okay. If you're ready, go ahead, turn it over to the next page. Okay, so what happens when it reaches 180 degrees? Well, we call that a straight angle. It is an angle that has a measure of exactly 180. And if you'll notice, that diagram looks exactly like a line because it is a line. A straight angle is the same thing as a line. So lines have a measure of 180 degrees. We could say this angle, the measure of angle ABC, equals exactly 180 degrees. Questions there? Okay, next is congruent angles. We've seen that word congruent before, right? We saw it in that lesson about segments. Congruent just means they have the same exact measure. So in my diagram here, you're going to see what our tick marks for angles look like. I have these two angles here and here. They each have one tick mark. They both measure 65 degrees. So I could say that those two angles are congruent. Again, I don't need to write the M for this. I only do that when I'm talking about degrees. I could say angle ABC is congruent to angle DEF. If I have more than one set of congruent angles, I just start adding on tick marks. So here and here, they have two sets of tick marks telling me that those two pieces are congruent to each other. So I could say angle CBE is congruent to angle DEB. There's a few correct ways that we could have written these angles in purple too. So if you didn't write it exactly like me, that's okay. Questions there? Okay, for this last part, I'm going to introduce you to a little bit of like proofy language that we're going to get into more in the next unit, but I'm going to introduce it right now. I'm going to use this abbreviation in a second. IFF. It stands for if and only if. And it basically means that a statement that has this abbreviation in it can be read backwards and forwards. I'll make it make sense in a second. We got that little note in there? So the last definition here is an angle bisector. An angle bisector can be a bunch of things. It can be a ray, a segment, a line, a few different options here. But it basically divides an angle into two congruent angles. So I have this angle right here, XYZ, and it is being bisected, or remember that word bisect means to cut into. It's being cut in half by that ray YW. I can tell it's being cut in half because of those angle tick marks here and here, and that the fact that they're both 80 degrees. So a statement, using that little abbreviation I just told you, says that ray YW bisects angle XYZ if and only if, IFF, the two pieces are congruent. So angle XYW is congruent to angle WYZ. Okay, so what does that mean? As somebody who's looking at these diagrams and trying to prove things or solve things, this says I can see this in two different ways. If I am told in my problem that YW bisects that angle, then I can make the assumption that those two pieces are congruent. Okay, then I'd be able to do whatever with my solving. The IFF, if and only if, tells me that it also works backwards. So if I see in a diagram that I have two pieces congruent and there's a ray or a line in the middle, then I can answer something about that segment or ray that it is an angle bisector. Okay, that's all that if and only if thing says. It says that that statement is true both ways around. Questions about that? Kind of tricky language. We will get into it when we talk about proofs. Okay, that's all the definitions. So let's do these examples. In example 1, I'm looking at this figure, and I first want to name some angles that have B as a vertex. There's a bunch of different options here. Can I get one correct option? An angle that has B as its vertex. Yeah. You said EBD? Perfect. Oops. Can I get one that's not 3 letters? What's another option other than using 3 letters? Any ideas? Remember that one of our options was I can literally just use those numbers that are in there. So an angle that has B as a vertex, can I call one angle 5 here? That works perfectly fine. There's a ton more, but I'm not going to go into them all. Letter B, name the sides of angle 5. Anytime I'm asked to name the sides of an angle, my answer should be rays. So I'm going to highlight that angle for me. The sides of angle 5. Ooh, right here. I got 2 rays that make up that angle. They are BG. Again, got to make sure I got correct ray notation. And B, I'm going to say BE. You could also say BF. That refers to the same ray. Questions there? Okay. Another name for angle 6. Instead of using that number, remember that we can use our 3 letters. So I'm going to call that one, B is my vertex, so I got to make sure B is in the middle. I'm going to call that one EBD. We could call it DBE, we could call it DBF, we could call it FBD, right? There's a lot of options here. Any questions on that first problem? Number 2, use the figure below to answer the following. Classify angle VYX as right, acute, or obtuse. Here is VYX. I strongly recommend we highlight things in these diagrams. What is that one, right, acute, or obtuse? What do we see in there, Gabby? Yeah, how do you know? Yeah, it's got this little box. So this one is right. And then what about the next one here, WYT? Let's highlight that one, WYT. Right, acute, or obtuse? Obtuse. It is obtuse. Why do we know? Just looks like it, right? It looks like it's bigger than 90. I know I have a right angle right. Oh, actually, I don't know that I have a right angle right there. Well, it looks like it's bigger than 90, so we're good. It's obtuse. Questions? Okay, 3 more, and then I promise we're done. Find the measure of angle BHC and the measure of angle DJE if BHC is congruent to DJE. This automatically tells me what about the equation that I'm about to set up? Casper. They are going to be equal to each other. I know that the measure of angle BHC is equal to the measure of angle DJE. So when I have these pieces here and here, I can set them equal. 4x plus 5 equals 3x plus 30. This should be a nice, easy solve. I move all my x's to the left. X equals 25. I got to be careful because I'm not quite done. They did ask me to go back and find the measure of these 2 pieces, BHC and DJE. So let's plug those in really quick. BHC is equal to 4 times 25 plus 5, which is 105 degrees. Sorry, I'm getting real small over here. Same thing for DJE. I could plug in that 3 times 25 plus 30, or we know they're congruent, we know they're equal. I know that this has to be also 105. If I want to plug it back in anyways, just to check my work, I can do that. Any questions on that one? In the figure, KJ and KM are opposite rays, and KN bisects angle JKL. What does that mean? What the heck does that tell me about this diagram here? Any ideas? How about this part right here? What does KN bisects JKL? What does that mean? Casper? Yeah, it splits it exactly in half. Here's KN. Here is JKL. That means that the two pieces of that angle are congruent. Here and here. Then let's just fill in the rest of this, right? JKN is 8x minus 13. NLK is 6x plus 11. Exactly like we did in the last problem. I know they're congruent, so I should be thinking, set them equal. Again, kind of a nice easy solve here. I get 2x equals 24, or 12 equals x. And then I got to plug it back in for angle JKN, which isn't too bad. 8 times 12 minus 13. 96 minus 13 is 83 degrees, I think. Something like that. Questions? I got one more for you, then I'll let you go. Refer to the figure. If angle MPN equals 2x plus 14 and angle MPR equals 5x plus 2, find x and find NPR. We got to label this stuff. So I'm going to pick angle MPN is 2x plus 14. That's this guy right here. And then I'm also told that MPR, this guy right here, the whole thing, is 5x plus 2. What do I see about this diagram? How is that going to help me set this up? What do I know? Dahlia.
You can double the first equation.
Yeah, why do we know that? Yeah, we see these little congruent tick marks here. That tells me this is also 2x plus 14. So I can double it, set it equal to my total. Okay, two pieces equal the total. 4x plus 28 equals 5x plus 2. I believe that we get x equals 26 here. And then we got to plug it back in to find MPR, which is 5 times 26. No, is that right? No, sorry, 2 times 26. I'm finding NPR. Which is 66. Any questions on that?